The selection of the canal blocking types. To implement the Article 16 of the Minister of Environment and Forestry Regulation number P16/Menelhk/Section/Co/1/2/2017 regarding the technical guidelines of the rehabilitation of the pit ecosystem, we need to restore the pit ecosystems through the development of the rewetting infrastructure. Restoration of the pit hydrological functions could be effectively done by observing socio-economy and culture of local community, including community customs, community livelihood, and the local wisdom. In order to determine the right and effective number of the rewetting infrastructure, which are canal blockings and or canal backfillings, availability of the following data should be taken into account, including topography of land, pit depth, dimensions of canal, water debit, availability of raw materials, and accessibility. Selection of a canal type is determined by the function of the pit ecosystem. For the pit ecosystems with protection function, it is recommended to use the canal blocking without spillway and equipped with a ramp or roller for mobility. For the pit ecosystems with cultivation function, it is recommended to use the canal blocking with spillway, which is necessary to regulate the pit water level of not exceed 0.4 meter below the pit surface. The types of canal blocking design. The design type of canal blocking depends on the physical conditions and dimensions of canal, or length, width, and depth. Topography of pit, the availability of raw material for canal blocking construction, and accessibility. Construction of the canal blocking needs to note the foundation or pile has to penetrate the soil mineral layer. There are some types of canal blocking design. These are one layer of plywood or a plank dam. This type of canal blocking is generally used for small canal or water channel less than 2 meters with a relatively small debit of water flow. Multiple sheet piles dam. This type of canal blocking is commonly used for a large dimension of canal or water channel more than 5 meters because it can withstand relatively large pressure and water, constructed with vertical lines. The construction is consisted of more than one layer of round wood, and between the round wood layer is filled with sacks of mineral soil. It is not recommended to use sand as filler material since the sand can be easily swept away by the water when the sack is torn. Before the sacks are filled with mineral soil, the inner layer must be coated with a tarpaulin or geotextile to reduce water seepage. Soil-based dam. This type of canal blocking is used for small, narrow channel canal less than 2 meters and shallow, can be equipped with spillway or non-spillway. The construction can be either by filling mineral soil into a sack that being prepared to reduce the water flow and maintain a high water table. Compacted pit dam. This type of canal blocking can be used in open dimensional canals more than 5 meters, can be equipped with spillway or non-spillway. This type of canal blocking is constructed from the compressed pit by putting bulk of pit using bucket excavator or stamper to form the dense and stable layer of compacted pit that is able to withstand the water flow and maintain the high water table. Concrete dam. The type for the canal blocking can be used for medium to large dimension of canal, more than 2 meters. It is usually applied to the canal with 3 to 20 meter width on the location with a thin layer of pit dam, and a layer beneath the pit is a mineral or alluvial. The mineral or alluvial soil is relatively adequate to support the concrete structure. The concrete dam may be equipped with a water level device and can be equipped with spillway or non-spillway. The concrete dam can withstand a relatively large flow of water and maintain a high water table. It is recommended to be built on neighboring canals and near into a river or a beach. Precast concrete. This type of canal blocking can be equipped with spillway or non-spillway. It is used in medium-sized canal, more than 5 meters, on a location with a thin layer of peat, and the soil layer is relatively adequate to support the precast concrete. The precast concrete is installed into the canal. The use of this type of canal blocking should be avoided in the conservation area. Floodgates. This type of canal blocking is used on a small canal, less than 3 meters. The primary function is to regulate the water level, can be equipped with spillway or non-spillway. The water doors must be strong, tied to the walls and the bottom of the canal to avoid leaking. Determination of location and quantity of canal blocking and or canal backfilling. In determining the location and number of the canal blockings and or canal backfillings, the following aspects should be taken into account, including topography of land, pit characteristics, including pit depth. The water management zone is based on contour. The use of maps or thematic maps should revert to the one map policy, as the data necessary to identify the location includes topographic surveys, land use planning, pit characteristic including depth, number of canals, distribution of canals, direction of water flow, water debit, biodiversity, the current state of the burning, rainfall data. Once the data are collected, it is followed by spatial analysis to determine the number and location of canal blocking or canal backfilling construction in order to effectively restore the hydrological function of peatland ecosystems. The steeper of the peatland contour, the more number of canal blocking must be built, and the closer distance between each of canal blocking. The lesser steep of the peatland contour, the lesser number of canal blocking should be built, and the far distance between each of canal blocking. The formula that is used in determining the number and distance between the canals is H equal difference of maximum elevation of each canal for every slope. D equal distance per part of the slope. S equal distance between the lines. N equal optimum number of canal blocking. There are several aspects should be considered in the site selection for construction of rewetting infrastructure, including spatial planning based on peatland ecosystem function, social aspect, area of burn-to-burn regions that have massive canals, an area located at the top of peat fault, and a conservation area.